Suppose that for all x on a closed interval AB, except possibly at x equals c, we have that f of x is less than or equal to h of x is less than or equal to g of x. Also suppose that the limit as x tends towards c of f of x is equal to the limit as x tends towards c of g of x equals L for some c in this closed interval. So c could actually be equal to a or equal to b or anywhere in between it. Then the limit as x tends towards c of h of x is also equal to L. Now, the functions have to be related to each other like this everywhere in the closed interval from a to b, except possibly at x equals c. So what does that mean? Well, it's quite possible that there is a discontinuity at x equals c for the function f of x. As a matter of fact, f of c could be, say, this value here. F of c could be this point here, so we would have to remove a point from the graph of f of x. It's possible that that's the case for all three functions actually. H of c might be this point here. And we could make g of c this point here. So as I said, this point is removed from the three curves if this is the actual graph of the function. Now you can see that at x equals c, this relationship does not hold. H of c is less than g of c in this case, but g of c is less than f of c, whereas we want f of c to be, well, in general we want f of x to be less than or equal to g of x, and that doesn't happen at x equals c if this is the situation. Okay, so that's really just a small point, but I think it's worth mentioning. So the functions could have a discontinuity at x equals c, or they might not even be defined at x equals c. So we would just remove this point here and have that f of c does not exist. Anyway, what does the limit as x tends towards c of f of x mean? Well, it means that if we approach c from either the right or the left, then f of x approaches L. If we plot the y values for all points along here in the neighborhood of c, we will find that as we approach c but never reach c, then f of x approaches L but never reaches L. And similarly, the limit as x tends towards c of g of x is L. Now we are going to prove that the limit as x tends towards c of h of x equals L. So h of x is squeezed between f of x and g of x. Now we want to prove this limit here. So to prove it, we pick our epsilon greater than 0 from the outset. We then use the fact that the limit as x tends towards c of f of x is equal to L. That's the function shown in green here. If that's the case, for this epsilon greater than 0, there exists a delta 1 greater than 0, such that whenever x is within a distance delta 1 of c, but x is not equal to c, then the magnitude of f of x minus L is less than epsilon. Now, we can write that in a different way. We can write that as minus epsilon less than f of x minus L less than plus epsilon. So that's what it means for the magnitude of f of x minus L to be less than epsilon. If we remove the magnitude lines, then f of x minus L could be negative, which will happen, of course, if f of x is less than L. So our interval from L runs from L minus epsilon to L plus epsilon. So f of x could be less than L. So as long as the distance of f of x to L is less than epsilon, then we're okay. But f of x minus L can be negative, but it has to be greater than minus epsilon. So that's just the meaning of this thing here. Now, since we're given that the limit as x tends towards c of g of x, the red function is L, we can also apply our epsilon delta definition. So for the same epsilon that we're going to use to prove our final result is here, we can say that there exists a delta 2 greater than 0. such that whenever x is within a distance delta 2 of c but x is not equal to c, then the distance of g of x to L is less than epsilon. So we just rewrite this here. If the magnitude of a quantity is less than some number, then the quantity itself lies between minus that number and the positive number epsilon. Now we are given that the three functions are related like this for all values of x in the closed interval a to b, except possibly at c. But we're not interested in what happens at c, because we're taking the limit as x tends towards c. So x never actually equals c. So we don't have to worry about what happens at x equals c. So we could even state that x is not equal to c here for this relation. So next we subtract L from each term. Let delta be the minimum of delta 1 and delta 2. That means that whenever x is within a distance delta of c, but x is not equal to c, then this relation holds. Why is that? Well, if we go back up here, we see that if the distance between x and c is less than delta 1, then this relation holds. But delta is less than or equal to delta 1. So that means that x is within a distance delta 1 of c. And if it's within a distance delta 1 of c, then we have this relation here. Now, since delta is less than or equal to delta 2, because it's the minimum of these two deltas, we see that x is within a distance delta 2 of c. And we know that if x is within a distance delta 2 of c, then this relation holds. So I've written it down here again. So what does that tell us about this relation? Well, minus epsilon is less than f of x minus L, and that in turn is less than or equal to h of x minus L, which in turn is less than or equal to g of x minus L. And what do we know about g of x minus L? Well, when x is within a distance delta of c, g of x minus L is less than epsilon. But now you can see that h of x minus L is obviously between minus epsilon and plus epsilon. And what's another way of writing that? Well, the magnitude of h of x minus L must be less than epsilon. So what have we shown? Well, if we pick an epsilon greater than 0 from the outset, which is what we did at the very start, then we can find a delta, such that whenever x is within a distance delta of c, but x is not equal to c, the magnitude of h of x minus L is less than epsilon. Well, that just tells us that the limit as x tends towards c, of h of x is equal to L. That's what we set out to prove. So it doesn't matter what our epsilon is at the start, some positive number, we can always find a positive number delta